Hello everyone. So today we are going to discuss about the speed study, and this lecture will be focused on the spot speed. So basically, there are two type of speed study. The first is spot speed, and the second is speed and delay study. So as the name suggests, in your spot speed, we are interested in the speed of the vehicle that is crossing a certain road section, or the speed of the vehicle at any instant. So suppose if we have a road section that is under our observation, so what is the speed that has been maintained by the vehicle that is passing through this road section, or what is the speed of the vehicle at any instant of the time. So the second is your speed and delay study. So in the speed and delay study, we are interested in the average speed that has been maintained by the vehicles between 2 points, and what were the cause of the delay. So for these we use a variety of speeds. We use a journey time, we use a running time, we use time mean speed, we use space mean speed, and I have discussed about these in the previous lecture. So if you so it is recommended to basically go and check those lectures, so as to get the better understanding of when to use which type of time and when to use which type of speed. Now these speed study data are used in number of ways. These are used for the traffic planning and regulation. So by knowing the average speed of the vehicle, by knowing the congestion points, we can understand the requirement of the traffic and what steps that are need to be taken for the smooth maneuvering of the traffic. These are also help in redesigning the existing highways. These spot speed data are used for the accidental studies and the traffic capacity studies. By speed study, we also find out the speed trend, that what is the speed bracket that has been maintained by the most of the vehicles, and what are the diverse traffic conditions that has been in the road section. So what are the vehicles that are moving in that road section, and what is the average speed that has been maintained by those vehicles. Now there are a number of factors that affect the speed of the vehicle. We have pavement width. So if wider the pavement, the more space is available for the vehicle to maintain a very high speed, and narrow width will lead to a very controlled speed of the vehicle. The second is curve. If a road section has more number of curves, then of course the speed will be less. Clear sight distance promotes higher speed, and pavement unevenness leads to a very slower speed. And then we have environmental factors that affect the speed of the vehicle. So basically, if we have more rain or foggy condition, then of course the speed of the vehicle will be less. So these are just the common points which affects the we all know about these, and these are factors that affect the speed of the vehicle or overall speed of the traffic. So now let us discuss about the spot speed. So as we have talked about it, there's in spot speed we are interested in the speed of the vehicle at any spot or at any road section or at any instant. Now for that it can the time mean speed can be used, the space mean speed can be used to find out the spot speed of the vehicle. Now there are some equipments that are used to find out the spot speed of the vehicle. First is anoscope, then we have radar, then we have electronic meter. Here it should be noted that anoscope is we should remember that, because many a time in competitive exam it is asked that what purpose the anoscope is used. So anoscope is used for the speed study, and to be specific, anoscope is used for the spot speed study. So let us discuss in brief what anoscope is. So basically anoscope is a very basic device. So suppose we have a road section, and this road section is under observation. So of course we know the length of this road section, and at one end of this road we have the observer that is noting down the vehicle that is entering the road section, and on the other side we have anoscope. So anoscope has a mirror, and this mirror enables this observer to see when the vehicle crosses this part of the road section. So as soon as the vehicle enters the road section, the observer starts the stopwatch, and as soon as the exits the road section, the observer sees through anoscope that the vehicle is exiting the road section. He stops the stopwatch, and we know the length, and through the stopwatch we know the time, and through that we find out the speed. So it's a very basic instrument that is used to do the speed studies. And in the night we have we have a light source that enables to reflect the light back to the observer, and through that we can carry out the speed study even at night. It's a very basic instrument, but then again in many competitive exams it has been asked that what is anoscope used for. So your anoscope is used for the spot speed study. Apart from that, we have a much more precise instrument and sensors that are used for the calculation of for to find out the spot speed. We have radars, we have electronic meters and other devices that find out the speed of the vehicle at any instant and in a very much precise way. Now let us discuss the data that we have collected, how these data are represented. So your spot speed data are represented first of all by average speed of the vehicle. So this is the most basic way of representing the spot speed data. Here what we'll do is whatever the number of readings that we have recorded, we will find out the average of that. So suppose for example we have like number of readings. We have 10 km per hour, 20 km per hour, we have 20.5 km per hour, we have 30 km per hour, and of course there will be repetition of speed. So let us say that we again have a vehicle that is passing at 20 km per hour. Then there are vehicles that are passing high speed. So let us say we have a vehicle that is passing at 60 km per hour, likewise 30 km per hour, 35, 38, and again let's say 30 km per hour. So to find out the average speed of the vehicle, what we'll do is we'll sum all the datas and divide it by number of values we have. So here we have 10 values. So what we'll do is 10 plus 20 plus 20.5 plus 30 plus 20, 60, 30, 35, 38 and 30 divided by 10. So this, let's say this comes out to be 29.3 kilometer per hour. So through this we find out that the average speed that has been maintained by the vehicles that are passing through that road section is 29.3 kilometers per hour. Let's round it off to like say 30 kilometer per hour. 29.5, 30 kilometers doesn't make much of a difference. So let's say the average speed that has been maintained by the vehicles is 30 kilometers per hour. So this is your average speed method. After that we have a cumulative speed of the vehicle method to represent the spot speed data. And here what we do is we draw a graph. Okay, so we draw a graph between the average speed group versus the cumulative percentage of vehicle that had traveled at that speed or below that speed. So what we trying to achieve is we are trying to find out the speed trend. So what is the percentage of the vehicle that are traveling at that speed or below that speed. So through that we come up with certain values. So we have like 85th percentile speed, we have 98th percentile speed, and we have 15th percentile speed. So your 85th percentile speed denotes that the 85% of the vehicles were traveling either at that speed or below that speed. Okay, so 85th percentile speed denotes that 85% of vehicles were passing at that speed or below that speed, and this 85th percentile speed is used as your speed limit. So whenever if you are going through a road section and if you see a traffic sign that the speed limit is 60 km per hour, so this speed has been defined by doing the speed survey, and through that survey it has been found that 85% of the vehicles were traveling either at 60 km per hour or below that. So that's how the speed limit of the road has been decided. But then the road is designed for the 98th percentile speed. So we know that not every vehicle will be abiding to the speed limit, right? So we have to take that factor into account to minimize the accidents and to give more comfort to the passengers. So for that the traffic is designed for the 98th percentile speed. So let's say during the survey time it has been observed that the 98% of the vehicles were basically traveling at the speed of let's say 85 kilometers per hour. Okay, so the road section will be designed for the 85 km per hour, that is 98th percentile speed. Okay, then you have 15th percentile speed, that is set as your lower speed limit. That is, this is the minimum speed that should be maintained by the vehicle to avoid congestion, and this is 15th percentile speed. That is, during a survey time we found out that the 15% of the vehicles were traveling at that speed or below that speed. So let's say 5 km per hour. We have found that around 15% of the vehicles were traveling either at 5 km per hour or below that. Okay, so these are the percentile speeds. The next way of representing the spot speed data is modal average speed. So through modal average speed, we are basically finding out that speed that has been followed by most of the vehicle. Okay, so here what we do is we again draw a graph and we find out the frequency distribution graph between the speed of the vehicle and the frequency of the vehicle that were traveling at that speed, and the graph comes out to be something like this, and through that we find out the speed that has been followed by the most of the vehicles. This modal average speed helps to decide or find out the speed trend that has been followed by the most of the vehicle. All right, so let us discuss about this cumulative frequency method and the modal average speed method through an example. So we have the data through speed study, and we use the same data for to study the cumulative method and study the modal average speed method. Okay, so the data will be same. So let's say the question asks us to find out the upper limit, lower limit, and the design speed limit. Okay, if the question says that we have to find out the upper speed limit, we have to find out the lower speed limit, and we have to find out the design speed limit, then it should be understood that we have to approach the question through the cumulative speed method, because through that only we have find out the upper limit, lower limit, and design speed limit, as we have discussed previously. Okay, so we have a different speed range. So we have vehicles, we have a speed range of 0 to 10 km per hour, and we have 12 vehicles that were traveling at this speed. Likewise, we have 30 to 40 km per hour, and we had 89 vehicles that were traveling in this speed range. Likewise, we have arranged these datas, and we have 90 to 100 km per hour. We have 9 vehicles that were traveling at this speed. So the first thing we'll do is we'll find out the mid range of these. So we have find out the mid range of that this speed. You have we have 12 vehicles that were traveling at 5 km per hour. We had 18 vehicles that were traveling at 15 km per hour. Okay, so these mid range are nothing but 10 plus 20 divided by 2, we have 15. We have 20 plus 30, that is 50, divided by 2, we have 25. Okay, so this is how your mid ranges find out. Now the next thing will be to find out the percentage frequency of the vehicle of each speed. So for that, what we'll do is we'll to find out the percentage frequency of the vehicle that were traveling at each speed, we'll first of all find out the summation of the overall frequency, comes out to be 850. Okay, so during our spot speed survey, we had 850 vehicles that were passing the road section. Okay, so out of these 850 vehicles, what was the proportion of these 12 vehicles? So that can be find out the percentage frequency can be find out by 12 divided by 850 into 100. So this comes out to be 1.41. Likewise, what was the percentage of the total vehicles? What was the percentage of the vehicles that were traveling at a speed of 15 km per hour? We'll find out by 18 divided by 850 into 100. So this comes out to be 2.12. So likewise, we'll repeat the same for everything. Let's do one more. Okay, so this is how we have to find out the percentage frequency. So here we have find out the percentage frequency. Now right now we have frequency. Now we will find out the cumulative frequency. So that is how we'll get the at or below speed. So the cumulative frequency will keep adding numbers. So here will be 1.41 plus 2.12. So this comes out to be 3.53. Then we have 3.53 plus 8. This is 11.53. Then we have 11.53 plus 10.47. So this comes out to be 22. Likewise, 22 plus 24 will have 46, and we'll do the same for each and every data. Okay, so this comes out to be something like this. Your cumulative frequency comes out to be these. Now what we have to do, we have to draw the graph between the speed and the cumulative frequency. So the graph, by plotting the values, the graph looks something like this. So these are the values that we have plotted. So let's join these values. So this is the graph between the speed and the cumulative percentage. Now we have to find out the upper speed, lower speed and the design speed. So your upper speed. So what is the upper speed? Is it 85th percentile speed? Is it 98th percentile speed? Or is it 15th percentile speed? Think about it. So your upper speed is 85th percentile speed. Alright, that is the speed limit. Your upper speed is the speed limit. Right. So your speed limit is 85th percentile speed. So let's say the 85th percentile speed lies somewhere here. So we'll draw here and then we'll draw here. So this, let's say, comes out to be 60 km per hour. So your upper limit will be 60 km per hour. Next we'll find out is design speed. So design speed is 98th percentile speed. So let's say 98th lies somewhere here. We'll draw the line and we'll draw that. So your 98th percentile speed, let's say, comes out to be around 80. I think 80 is fine here. So here, this is just for the example purposes. Whenever you're drawing in your graph copy, make sure that each scale is well defined, right? So here I'm just showing for the understanding purposes, but whenever you're doing the question in your graph, each value should be well defined. Then we have lower limit, and the lower limit is 15th percentile speed. Okay, so for the 15th percentile speed, so let's say 15th percentile speed lies somewhere here, and if we draw that, and let's assume your 15th percentile speed is 30 km per hour. I think this should be fine. Okay, so your low speed limit is 30 km per hour. So through this we find out the 85th percentile speed, which is 60. We find out the 98th percentile speed, which comes out to be 80, and likewise we find out the 15th percent. Okay, so this is how cumulative speed of the vehicle is used to find out the desired speed limits. Now let us attempt the same question through the different method, that is to find out the most preferred speed. And we have discussed that when to find out the most preferred speed, we use model average. Okay, so here what we'll do is, instead of percentage cumulative, we'll just find out the frequency of the vehicles. So we will find out the frequency of the vehicle. We have already discussed how this frequency is find out, and through this we plot these in the graph, and by plotting the graphs comes out something like these. So upon joining these, so here we already have a very definite peak, and through that we can find out. So let's say this is 55. Okay, so 55 km per hour is the most preferred speed by the vehicles that were traveling through that road section. Okay, so this is how the calculations are done. So I hope the spot speed is very much clear to you, and all the three methods of representation of the data and what does the technical terms that are included in these represent are very much clear to you. Still, if you have any doubt and if you want me to prepare a lecture for some any other topic, post fill in the comment section, and the speed and delay study will discuss in the next lecture. Thank you.